You revised all that? I will ask you which was. That means you have not revised. Light. It's nice. Yeah. Right. How did you forget? I think in advance, what has to be revised? Will you pass on the paper? Ah, yeah. That's it here only. Pass the paper. Are you? Any exams coming up? Exams, electricity is there or no? Like half chapter of electricity, human eye and identity. Okay, where's the sheet? Where's the paper? Pass it, pass. We are going to do revision of current electricity today. So take out your textbook, flip through the papers, at least you revise with your formulas. Papers. How many of you already had this chapter, current electricity, for your school exams or anything? Ryan had it, that means. Which chapter? You side? Ukran, you side? It will be easy for you to study the chapter by looking at what we have already done in class. Okay. This chapter on electricity. Can be divided into two parts. Okay, you have your part A and part B. So I advise you to study it in two separate parts so that it is easy for you to remember. Okay, so the first part of it, of course, talks about current electricity, and the next part of it talks about the heating effect. So let's see what are the various aspects that we are going to be talking in terms of electricity. The first one being current. Okay. Along with your terms that we'll be talking, I want you also to revise what is the alphabet that we are going to use, as well as what is the SI unit. The first thing we talk about is current. Almai, what do you think is current? How do we define electricity? What is current? Flow of charges. What are these charges? Electrons. Okay. How do they go? From where to where do they go? Electrons are going from positive to negative. Negative to positive. So what is going from positive to negative? It is the conventional current. Okay, the conventional current. Be careful about this. Suppose I'm having a simple circuit like this, and let us say I have got a bulb or whatever it is. That's your resistor. This happens to be your positive terminal, and this is the negative terminal. When we talk about the flow of the conventional current, which is I, it is from positive to negative. Okay, this is for your conventional current. But what will we say? Current is nothing but the flow of charges. So when we talk about the flow of electricity or the flow of charges, electrons being negatively charged, it moves towards the positive direction. Okay? So the electrons are the ones which are moving in the opposite direction. Have you all followed? Okay, don't be confused about this aspect. Conventional current, or your sums, for whatever it is, we always have to take the conventional current, which is from positive to negative. But what is moving in the opposite direction? It is actually the electrons which are moving towards the positive terminal. Okay, why does this confusion come? Positive, negative, or the opposite direction? It means one and the same. That's because in the olden days, people did not know that it was the movement of the electrons. In fact, electrons were not yet discovered. So people like Ampere and other people, scientists who were trying to work with these type of experiments, realized that there was some kind of charges which are moving. So they assumed it was a positive charge, and that is how they have said this, it is from positive to negative. However, right now, of course, we know that it is the movement of the electrons. Now, coming back again to the symbols. How do we represent current? What is the symbol? I. Okay. And what is the SI unit? Ampere. SI unit is what? Ampere. So we are going to represent it as AV. Sometimes they may give you the value in milliamperes. Okay, in such a case, what will you do? You always have to convert it into amperes. Next, your question. Suppose I give you 2 milliamperes. Yourself. How will you convert it into ampere? How many amperes will that be? Milli. When I'm talking about a milliamp, okay, it is in terms of millimeter, milligrams. How will you convert milliliters into liters? Is it divided or is it multiplied by, and by what number? Come on, quick. You can't be thinking about it for such a long time. How many of you know the answer? There. How many you know the answer? Tell me what it is. You don't know? Tell me now. How will you convert 2 milliamps into amperes? Class? 10 to the power minus 3 minus. Yes, 1000. Okay, so we say that it is 1000 milliamps will make 1 amp. Are you writing down something? Am I telling you a story or something of that sort? If you don't know, you write it down. Most of you know it is okay. But if you don't know, at least you note it down, no? I don't know, and you're listening to me happily. So 1000 milliamps make 1 amp. Okay, now what have I given you? I've given you 2 milliamps. So it is 2 milliamp and I want to convert it. So it's obviously going to be divided by. So it is 2 divided by 1000. Or you can also say 2 divided by 10 raised to the power of 3. Or you can say 2 times 10 raised to the power of minus 3 amperes. Is that okay? Have you all followed? Did you understand now? Always remember the word milli. Okay, milliamps, millivolts, and you have to convert it into volts. It's obviously 10 raised to the power of minus. Okay, coming here once again. Similarly, not only micro, but we may also have a mega. Okay, mega is what?
10 raised to power 3.
3. Yes, mega is 10 raised to the power of 3. What is microamp?
10 raised to power minus 6.
6. Okay, so we have got milli, we also have got a microamp, and obviously we have got a megaamp. Okay. Now, next formula that we are going to be talking about is how do we calculate the current. So we said it is the flow of charges. And how do we represent charge? What symbol should we use? C. C? What is C? Q. Why are we getting confused between C and Q? What does C stand for? Coulomb. That happens to be an SI unit. But what is the term? Term itself is Q. Okay, so that is your charge. Now, how is Q and I related? What is the formula that
by T.
Yes. Okay, so you can also remember. You can remember this Q is equal to I to T, or you can say I is equal to Q upon T. Okay. Now, if I am asking you to, define 1 ampere. Gujarat, next year's. What is 1 ampere? How do you define 1 ampere?
1 coulomb of charge upon per second.
Okay, you are almost close to it. Yes.
When 1 coulomb of charge passes through a conductor
Yes.
in per unit time.
Cross section. Okay, that's a cross section per unit time. So by looking at this formula, so I is equal to Q upon T. Therefore, 1 ampere is equal to 1 coulomb divided by 1 time obviously. It is going to be 1 second. Okay, so 1 coulomb divided by 1 second. So that basically gives you your definition of 1 ampere. Have you written it down? Learn all these things. Why do you think I'm doing all this revision again? It is there in your book, I know that. Is that okay? You remember all this? Yes? Okay. Next we talk in terms of the work done. So when you're looking at the circuit, I don't know why the duster is so dirty today. Okay. How do we define potential difference? You remember what is potential difference? Okay.
Potential difference is
Work done to move a unit charge from one point to another.
Yes. You remember?
energy needed to move the electron across the circuit in unit time.
Time will not come. It is the work
Per
done.
unit charge.
Work done.
Yes, to move a unit charge from one point to another in a circuit, in an electric circuit. Okay, so it is in terms of the work done. So your potential difference is in terms of the work done. Okay, to move a charge. So you have got all these words. How do we put it down in the form of a formula?
E equal W by Q.
Yes, so always you can also say W is equal to VQ, or we can say V is equal to
W by Q.
W upon Q. Okay, so therefore it is the work done in order to move a charge from one point to the other in an electric circuit. Okay, fine. So what do we do? Right here now, what is the term here for potential difference? What is the
V.
Okay, and your SI unit?
Volt.
Also volt, which is equal to V. Okay, so you know about millivolts and volt in case they give. Now how is your W? What does W stand for? Work is the work done. Okay, so it is the work done, obviously it is going to be W. What will be the unit? Joules. You remember that? Okay, so it is going to be Joule, which is your SI unit. I am running through this table once again. I know I have given it to you because these are things that are going to be very, very useful to you. So in case somebody has missed out something, you don't remember anything, please jot it down once again. Okay. Are you okay till now? So we have spoken about current. We have also spoken about the potential difference. Okay. And now we will be talking a little bit more regarding the various. If you turn the pages, you know that I've come to page number 174. You look at the table there. There's a table which will give different type of symbols. Okay. So whenever you're talking about any simple circuit diagram like this, it consists of various symbols. How do we actually construct it? Sometimes such a type of a question is given. They may give you 4 or 5 and they may give you gaps inside the circuit diagram. They are asking you to construct this circuit using a couple of them. And what will be missing? Maybe they will give you a battery, they will give you an ammeter, they will give you a voltmeter, they will give you a resistance or whatever. So putting all of them together, you have to make a circuit. Tell me now, your chance. I'm talking about ammeter and about voltmeter. Okay? Can you think of differences between an ammeter and a voltmeter? For what it is used? Come, yes.
Used to measure it.
Sit down, sister. That's all. Sit down.
Ammeter is used to measure current,
Very good.
and voltmeter is used for measuring the.
Wait. When your chance came, you never answer. Don't prompt him now.
Voltmeter is used to measure the charge of a particular.
Not charge.
Volt of a particular resistor.
What is that?
Volt.
Volt is what? What does it measure?
Potential.
Correct. It is the
Potential
potential
difference of
difference.
a particular resistor.
Yes, a resistor. Next, another point. Can you think of it?
When an ammeter is connected in
Thank you.
series and voltmeter is connected
ये
in.
देखो कितना काला काला हो रहा है. ठीक है. Then sorry. Yeah, tell me.
An ammeter is connected in series and the voltmeter is connected in parallel.
Okay, suppose I'm having a resistor here. Okay, this is your resistor R, this is your key. Can I have an ammeter here?
Yes.
Yes, sir.
Yes, anywhere on the line.
Yes.
On the line I can have anywhere. It can be here, here, anywhere it can be. But remember, what is missing here is to show your positive and negative. Okay, what will this side be?
Negative.
What will this side be?
Arrow.
No, in terms of
Nah, acha,
positive.
positive.
It will be
Positive
positive.
and negative.
Because it's the positive which is connected to this part, and obviously it is going to be the negative. Okay? If you miss out such tiny details, you tend to lose marks. So that's why I'm also stressing again and again. Yes,
And what would happen if you would write minus first and then plus?
no, it doesn't mean. Actually, what does it mean when you're showing an ammeter in the key also? You're having a positive and negative. It is just showing you that this part of it is connected to the positive terminal. Have you followed? But for a battery, suppose a cell, and you're having a battery of cells, how do you show a single cell? One big line and one small line. Suppose I want to increase the current, what do we do? I
Increase
will
the
add
number of
more.
cells.
Okay. Can I write like this and leave it?
No. You have to
What should I do? Is this
join
correct?
the small one and
Yes.
the big one.
Okay, the negative should be connected to the positive and show that this part of it is connected, this part of it is connected only, then it's going to be a correct diagram. Take it down. You think you'll remember? Got it? Okay, you'll remember all this? Okay, fine. I'm telling you all those finer details that you might. Now children, see here, listen to me now everybody. Okay, all of you have run through one exam. Okay, you have a good idea of the lesson. Now these are the finer points that you must take care of. Okay, what should we do is to I want you to minimize mistakes so that you can maximize marks. Okay, do you understand? 4 M's you should remember. Why are you losing marks? It's because you're making mistakes. Maybe a big mistake, small mistake, whatever it is. You're going to minimize the mistakes, or automatically you will maximize your marks. Do you understand? So these are some of the finer details that you must keep in mind. Okay, that's why I'm showing you all these things. So even that half a mark you should not miss out. Okay, I'm sure all of you can do that. Yes? Okay, so this time definitely your marks are going to improve because you have learned all those final details. Okay, coming back. Right? So we were talking about what? We have spoken about the potential difference and we have also spoken about the work done, etc. etc. There's one more thing that I want you to pay attention to is regarding variable resistance. You know how the symbol is? You know how resistance can be drawn? Okay, that is your resistance, R. Okay, that is the resistance present in the bulb or whatever it is. How is a variable resistance going to be shown?
Number
You remember that?
Your arrow.
Arrow, yes. What does it mean? That you can change the resistance. Okay, and as you're changing the resistance, obviously you can also control the current. Is that okay? Have you all understood? Okay. Turn the page now. We are going to Ohm's law. What is Ohm's law? Now, think of the formula and then you can state it. You know the formula? Okay, very good. Ohm's law. Even children, one more thing. In case, during the examination you don't remember, think of the formula. By looking at the formula, definitely you can make up V is equal to I. Now tell me what it is. Okay, potential difference is equal to I into R. Okay, how will you put it down in the form of a statement? Directly, I'm giving you hint. Directly proportional, inversely proportional, ऐसे कुछ आएगा? What? What is it?
V is directly proportional to I upon V upon I is equal to constant.
I want a statement. I want a statement. Yes, ask that later.
The potential difference between the conductor is in fact directly proportional to the current going through it at a given temperature.
Yes. Correct. Okay. Why and provided they, of course, the physical conditions of the conductor does not change. What does it mean that whenever you are passing current to any type of a conductor like this, if it is getting heated up, then R can also change. Okay. Provided the temperature remains a constant, or provided the physical conditions of the conductor does not change. So how can you make out? We said that V is directly proportional to I. Your potential difference is directly proportional to the current. Okay. How can we have more current flowing through the circuit?
Increase the number of cells.
Okay. One, of course, is that. And what else?
Now, what was the question?
My question is, how can we increase the the current passing?
Increase the potential
Increase the
difference.
potential
Very good.
difference.
Okay. One is by increasing the number of cells. By increasing the cells, you can also increase the current. Okay. Second, are you following what I'm saying? Yeah. 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 Okay. Second is by increasing the Okay. No, we are increasing the potential difference. Remember the waterfall that we were talking about? Okay. Greater the distance, the greater will be the fall. The same way, if you want a greater current, obviously the potential difference has to be more. So you are going to increase the potential difference. Are we clear, children? Any doubt here? Clear? Okay. Now we come to V and I, we have already written it. R obviously is the the whole everyone resistance. Okay. So what will be the SI unit? Ohm. So this is the symbol that you are going to write, or you can also write it down as ohm. Okay. Now there is a graph which is given there. Did you notice that there is a graph? So graph of something versus something. So on the y-axis, and this is the x-axis. On the y-axis, what do we have? Potential difference. All of you, did you notice that there's a V there? Yes, there's a V, which shows that we are plotting. We are taking your unknown V, which is on the y-axis. And on the x-axis is your variable, which happens to be your current. Okay, so your current is, let us say 0.1 amp, 0.2 amps, or whatever it is. And here we are talking about voltage, which can be 1 volt, 2 volt, 3 volts, etc. So if you're plotting a graph of V versus I, you're obviously expecting a
Straight line.
passing through the origin. That has to be mentioned. Did you understand? What do you say? What is the characteristic of the graph? It is a straight line graph passing through the origin. Is that okay? Do you know that? Okay, right. How will we find out R? Can we find out R by looking at
Yes,
a plot like that?
yes.
All of you think I'm going to ask Gopran, but before that I want to ask someone. Divyanshi, can you answer that? Okay, find out R by looking at the graph. Okay, there are markings there. The values are already given on the graph. Okay, you know how she can answer that? V by? V by I will give you what? R. Okay. Suppose a value something like this, 3 and 2 and all that is given, what will you do? Right, you're right. Yes, what is the formula? Okay, now I'm giving you a graph like this. Suppose in the question paper they're giving you a graph like this. Can we find out R from this? How will you do? Same thing.
Substitute the values.
R is equal to V upon I. So I need to talk about V. For a particular V, let us see where it is cutting the I. Okay, your value of V is 3 volts. Your value of I may be 2.5, 3.5, whatever it is. That is going to be the value of R. It is nothing but the slope of the straight line. You're right. Okay? You're perfectly right. Okay, so slope of a line which is passing through. Good, now your question. Okay? I have a same graph here, but I have got another line which is, sorry, this is a straight line. Is this also valid for Ohm's law?
Yes.
What about the rest of the class? My question is, if there is a steeper line, the line is steep now. Is it valid for Ohm's law?
Yes.
Yes? Okay. Now, will R be more here? I'm putting it as A or I'm putting it as B. Is the value of R more in A or will it be
No.
more in B?
It will be the same.
It will be the same.
No, more in
Will it be A more and B less? Will it be same? Option अगर वैसा होगा, choice, multiple choice.
Constant है ना हमसे.
What's your answer?
More in B.
More in A?
More
Why?
in B. The resistivity is more in B, right?
So let's look at this steep line here. Pay attention. One, of course, we are having like this. Okay. Now I'm going to draw another line which is a steeper slope. For the same value, let us see what is going to happen. Okay. R is equal to V upon 9. Suppose this is the value of V. Okay. This is the value of I, and this is V. Which is more? V is more. I is less.
Yes.
If I is less, what happens to R?
Resistivity is more.
So greater the slope, the
More the
greater will be
resistance.
the resistance. If the slope is like this,
The
resistance will be
resistance.
less. Okay, did you understand? Okay.
But
When did
that
you
is a
say, yeah,
constant.
when did you say it is a constant? For a given set of values. Suppose I am performing, I have taken, let us say, 6 readings here. For all the 6 readings R will be a
Okay, on a
constant.
straight, on the same
On
line.
the same. So for which I want you to refer to your questions given behind. So I think it is this question number 7 or 8. There's one raw graph with the values which they have given. Given. 7. Question number 7. The main questions which are given here. If you see question number 7, what have they given you? They have given you a set of values. Don't talk, please. They have given you a set of values for V. They have given you a set of values for I. Okay. Mentally, can you just work out and see if the value of R is a constant there? It's not a constant. Randomly just take any two numbers and work out and see whether R is a constant. It's not a constant. See, once again. Why? Why not?
This is into 2, and but this is not into 2.
Not necessarily. I said it's a ratio. Did I tell that it is double?
But
Take down everybody, take down.
We have to find it.
You have to find out R. Yes. I have to find out R.
if here it is multiplied by 2, then here also it should be.
See, we're talking about the value of R. See value of R here, see the value of R here and tell me. Come on, quickly. Do for the first 2, 3 and tell me what is the value of R.
3.2. Second one is 3.4.
Then
No, ma'am, it's not.
approximately tell me whether it is correct or not.
No, ma'am, it's not.
Why not?
Ma'am, because R1.
Do the next one. How much will be the next one? 6.7 divided by 2, it is 3.35. Correct? 3.4. Correct.
Ma'am, it's somewhere in 3.1
Yes.
is changing.
Yes, because it is an experimental value. So there's always a error which may be present. So the average of it is correct. So that is how we tell. Suppose a student is conducting an experiment in the lab. There could be a little bit of error. Okay, but as long as you're getting an average value of whatever it is, 3.4 or 3.5 or whatever it is, then we know that the value of R is going to be a constant.
And these circuits, like if we when we perform in school, where we made or we have to make it.
It depends. It depends on the school. Some of the schools have the apparatus. You just have to do the connections, take the reading. Okay, what readings will you be doing? You take a potential. Okay, V reading and you will also take an I reading. Ammeter reading and potential meter. Okay. Sometimes the schools will give you the entire thing and then you have to do the connections.
Our school doesn't get no marks.
You never perform the experiment.
No, not right now, because
My
the chapter
school
just
doesn't
started.
Never in chemistry, never in.
We have performed experiments, as when we started.
Okay, fine.
So the value of R is what?
Yeah, for a given resistor. For a given resistor, it is.
Ma'am, if like the decimal fluctuate a bit, it's pretty nice. Like if it's like.
Okay, suppose, suppose it's 3.2 or 3.3, we still accept it. That's not much of a problem. Is that okay, children? Have you all followed? Okay, are we done with Ohm's law?
Yes.
Yes, here, you will be able to answer such type of questions. Okay. Now, next we go on to the other concept. What does R depend upon?
Length of a conductor and the area of the cross section.
Yes, very good. Okay, so now what are we going to talk about? What is the concept?
Resistivity.
Resistivity. Is resistivity the same as resistance? No. Okay, fine. Tell me something about resistivity. What is resistance? You said resistance. Okay, now we are talking about resistance. What does it depend upon? Achita, come on.
Length,
Okay,
area of cross section.
okay. Tell me in terms of increasing, directly proportional, inversely proportional. R is directly proportional to what?
Length.
Length. Okay, and inversely proportional to area of cross section. Okay. What does it tell us? If we are increasing the length, what is happening? Resistivity is not resistivity.
Sorry,
Resistance.
resistance.
It is resistance which is increasing. Have you followed? Suppose you have a wire and you are increasing the length. Obviously, the electrons to flow through the entire length, the resistance is increasing. What happens if I'm increasing the area of cross section? Less. If at all this is the area of cross section, it's very difficult for the electrons to go. Suppose I take a bigger one. Remember the people who are going in a tunnel, that is what I had explained. So it's easy for those electrons to move. So it is inversely proportional to cross sectional area. Now what is the constant here? R is equal to rho L upon A. Okay, what is this rho? Resistivity. Resistivity. Okay, so first of all, let us write down resistance, which we have already written as unit as ohm. Now, how am I going to rearrange this formula? Okay, Alia, tell me, resistivity is equal to what? Rearrange these terms in the formula and tell me, is equal to, very good, R upon N. Okay, now based on this formula, can you think of the units? What is the unit of resistivity? Ohmmeter by. What is this R? So what is the unit of resistance? Resistance. Ohm. A is what? Area of cross section is what? Meter square.
Yes.
What is L? In terms of meter. Okay, now tell me. Okay, R is in ohm, area is meter square, and length is in meter. So this gets cancelled out. So what is the unit of resistivity?
Ohm meter.
It is ohm meter. Do you remember all this? Do you remember? Yes? Yes, you remember? Okay. Now, Divyanshi, resistance and resistivity. These are two terms that we are talking. This is not working, but it's so hard. Resistance and resistivity. Bolo. How do we differentiate resistance and resistivity? R and rho. How do we differentiate? Yes. Why do you go black?
Resistivity.
Wait, 1 minute. Think carefully. I put up everything on the board, no? Now you can do. Come on. Don't be scared. Come on. You should think and do it. What is resistance? You can use any 2 points. I put up most of the points on the board. Come on, think fast. In terms of anything, whatever you like. There are 3, 4 points. Any 2 points you can tell. Tell in terms of unit. Come on. I'm talking in terms of units. What is the unit of R? Yes, come on, class. Ohm. What is the unit of ohm meter? What is the other point that you can think of? Abhishek?
Depends on length and
Coiling of
Huh?
coiling.
What? What filing? Good. Good.
Like, yes.
What is R? Difference between R and rho. Both jaldi bol. Anybody? Anybody? Come on. Yes. Want to answer? Want to answer? Tell bol.
Load depends on the resistivity depends on the nature of the material,
Yes, very good.
whereas resistance depends on is directly proportional to the length and inversely proportional to the area.
Okay, very good. We have already said no. It depends upon R is depending on L and A. Okay. So we know that resistance is depending on length and area, whereas resistivity depends upon the material. Second point we can also tell in terms of units. What is the unit of R? It is rho. I've already written it down. Unit here will be what? Ohm meter. Is that okay? Yeah? Okay, fine. Now there's one table there. Look at your textbook. What is
Not
it?
the value.
No, not the valuation. I don't want you to learn and don't disturb us. You know it is perfect here, like don't disturb us. Okay? There is a table there. If you look at the values, you will find that the values are increasing or decreasing from the top to bottom.
increasing.
Is it decreasing or increasing?
Increasing.
Increasing, because the first few of them are 10 raised to the power of -8. Then slowly, slowly it is increasing. Okay? So if the resistivity is increasing, who is disturbing you? Why are you getting? Then why are you asking him to look back and all that? Please no. Please concentrate. Look, boys, you people are not doing me a favor by sitting here in the class. Okay, resistivity. What does it tell us about the material? If the resistivity is increasing, what does it tell us? What type of a material does it become? It becomes insulator. Okay, so if it is a very good conductor, which is the best conductor?
Silver.
Very silver. Silver is the best conductor because it has got very low resistance or resistivity. irrespective of the length that you take, resistivity value will not change. It will remain the same. Did you understand? Okay, suppose I take half a meter or if I take 1 meter wire of silver, will the resistivity change? No, it will not become half. It will still remain the same because the value depends upon the material that you have taken. Is that okay? Yes? Next one. What are we talking about now? Series and parallel? Yes? What are we talking? Series and parallel. Suppose I'm having something like this. Okay? I am giving you the values of R1, R2 and R3. Take it up. All of you please take it up. I want you to give you, let us say these are 6 ohm. Each of them is for 6 ohm. Do it. All of you please take down the diagram. Tell me what is the effective resistance in this series.
Resistance.
And I want you to find out.
What is the current path?
Why current? I'm asking R only. Why you need current now? Series and parallel. This is in series and parallel. This is a combination of series and parallel. I'm asking you what is the effective resistance. Okay. Remember the formula? RS is R1 plus R2 plus. Okay, if it is in parallel, it is equal 1 upon R, 1 upon R. So do it. So you should recognize, okay, what is in series and what is in parallel. Just show me with what is the answer. Come on, Kaushik, quickly. Got it? Find out which is in series. Whatever is in series, you have to add it up. That one will become parallel for the other one.
Jar.
Got it? How will you do? Okay, now. Ufran, tell me how you have done.
Ma'am, R1 and R2 are in series.
Okay.
So the resistance on the top one will be 12.
Yes.
And the new resistance and R3 are in parallel.
Yes, very good. That's all. Did you understand? Okay. So here, this is, look at the board. Those of you who have not got it, look at the board. R1 and R2 are in series. So 6 plus 6 will become 12. Okay, so this is your new 12. This is going to be 12. Did you realize this 12 and 6 are in parallel? Okay, so that's in parallel. So 1 upon 6 divided plus 1 upon 12. So it is going to be your answer. Is that okay? Did you get it? Okay. Then take down another one. Such type of combinations can definitely be asked. Now here what did I give you? I've given you something like this. Okay. And we have got the answer as 4. Now suppose I give you something like this. Okay. Same thing. Why do you say it?
9.
All of you do this one. Take down this one. Got it?
I did a contact.
And
What
first,
happened?
the first one is the same.
No, first one is different. This is what I had given you. You got the answer as well. No? This one I want. How many of you got the answer? 1, 2, 3, 4, 5. 6, okay. Okay. Finished? Finished? How much again? Kaushik, what is your answer? Look at the second figure here. Okay, let's label it as R1 and R2. It becomes easy. This is, let us say, R1. This is your R2. This is your R3. Okay, can I add up R1 and R3? No. First, you should see which is in parallel. Which two are in parallel? R1 and R3. So 1 upon 6 plus 1 upon 6. How much will it be? 3. 2 by 6 inverted to 6 upon 2, which is equal to 3. Now this value of 3 is in series with 6. So your answer is
9.
Do you understand? Let's try to do this. Okay, take down this.
Same as
I'm just giving you values. I want you to find out. Let us say this is R1. All of you please draw it.
all
Huh?
of them are 6.
All of them are 6.
No, I don't want you to draw, right? I'm not giving you any number. Just tell me in terms of R1 and
That is
R2.
easier now.
From R4.
That number is easier.
Done.
Yes, one can be a number.
Again together.
Okay, try with 6.
6.
Try with 6. Okay, try with 6. Do now. Okay, I know you can do it mentally, but I want you to. First, recognize if there are any series connection. Where is your diagram? Where is your diagram? Huh? Oh my God. Again, you will forget. Why will you not? Come on, hurry. Take it down for revision. Anyway, there's revision. Why confirm they're there? You're going to do all of them.
6, right?
All of them are 6, yes. How will you do that? You put your finger at some of those. This is steps. What is the answer? 3. How much did you get, Abhishek? क्या हुआ? Why are you looking so dull? What happened? Asta, check your answer once again. Are how much you got? Then you got a wrong answer, why?
What's the answer? 3. 3.
Kaushik? What? Okay, let's look. Let's look at the board. R1 and R2. How are they connected? Series. Okay. ठीक है? And R4 and R5. How do you know whether it is in series? Okay. We just have to see the passage of current. So we can see like that passage of current is like this. That is in passage of current is like this. This is the passage of the other one. So it is 6 plus 6 is what? 12. This is 6 plus 6. That is another 12. But you have got 12 and 6 and 12 in parallel. That's all. Did you understand? Okay. So that is 12 on the top. In the middle you are having 6. Then again you are having 12. Those 3 are in parallel. Okay, so it is 1 upon 12 plus 1 upon 6 plus 1 upon 5. Did you understand? Anybody who did not understand, please? Okay, so such type of questions will definitely be asked. Boys, are we okay with this? Okay, right. Okay, so now let's revise quickly. Okay, can I have some attention here, please? Look at the board. Now we have recognized what is series and what is parallel. So whenever we are having series connection, as in, I'll look at this diagram only, it's easy to explain. R1 and R2 anyway, we have realized it is in series. So it is the same current which is passing. Do you understand? And in a series connection, will the effective resistance will be more, will it be less, or will it be same? Objective type questions, MCQ.
Can you repeat?
I'm repeating carefully. In a series connection, the effective resistance will be more, will it be less, or will it be the same?
More.
Or I don't know.
More.
You have an option of I don't know, you can pick a mark.
More.
More. Obviously, 6 plus 6 is more. So effective resistance is definitely more. What happens in a parallel?
Less.
It is less. It is less than the least. Yes, it is less than the least. That is something that you have to remember. What about the current? Current is the same current passing, okay, in RS, but in RP, the current is splitting into different channels. Is that okay? Come to the next page. Are we okay? Are we okay? Yes? Go on to the next page. Now we are going to talk in terms of the heating effect. Okay. What is the law here for heating effect? Joule's law. Anybody remembers Joule's law?
Yes. Ma'am, I had a doubt.
Huh? Yeah, why?
है ना?
First time you're thinking
है ना statement?
Joule's law. Second part of the lesson
हाँ,
is
है ना
entirely.
statement?
There's a statement. There's also a formula. At least you remember the formula. H is equal to
I square RT. Ma'am, just a Ma'am, here in the statement it is like the heat is directly proportional to the square of the current and the time taken. it is like H is directly proportional to I square T. And then to remove the proportionality, we add an R, right?
Resistance also. No? If you see, as the resistance is increasing, what happens? The current comes in.
No, ma'am, no, ma'am, I'm not asking that. In the proportionality sign, R is not there, right?
It's directly proportional to the current. It is directly proportional to R also. Here. Where you are saying R is the time.
When we write the statement, we first show that H is directly proportional to I square R. And then we remove the add R square R. So here, when there is proportionality sign, R will not be there.
But what happened given in the sentence?
No, in exam, I did not write the R. When the examiner wrote R here, I got half mark.
Okay, but what is the question?
Ma'am, we had to explain that. No, equal to, below, I did this. I did not write R here and below I write equal.
Was it only a statement or was it the formula?
Yes, ma'am. I wrote directly proportional and then wrote equal to. I did this. I then I boxed and it's a half of it, 1 mark.
Okay, thank you, class. Thank you.
Now I come on Friday.
Not on Friday, I'm not coming on Friday.
Next Wednesday.
There's a class on Wednesday, if I'm not mistaken.
Yes.
There's a class on Wednesday. You want to do chapter number 1 is no chemistry.
Yes.
Yes. Chapter 3, better than others.
वो तो clear था.
Acid basis in the first chapter you might have forgotten. That's why I want to revise
Yes,
it.
ma'am.
All of you please write down.
Magnetic.
Time permits, we'll take it.
Right
Write down
now,
everybody.
we will all be
Very quickly. Okay, revision on first and second chapter, chemistry. If time permits, I'll definitely pick up magnetics. Magnetic effects of current elements. Thank you, class. They revise and come up,
Yes.
all of you. Don't say I forgot. Does that work?